Hey, I'm Zainab Suda Azdinch.
Composting is the process of decomposing organic wastes by fermentation and turning them into organic components to be used by plants in the soil. The compost formed at the end of the process increases the amount of organic material, porosity, and water holding capacity in the soil and destroys pathogens. The use of compost will ensure continuity in agriculture by reducing the usage of chemical fertilization and improving the damaged lands that cannot be used because of fires, erosions, etc. The engineering design cycle was used as a method in the project, aiming to develop a device for speeding, analyzing, and tracking the composting process. Steps in the development of the prototype were mechanical design, biochemical studies, electronic components, and software. Composting was achieved in a shorter time with the mixing mechanism and bokashi serum. And the values such as gas densities, temperature, pH level, humidity, and weight were monitored with the help of the sensors throughout the process. The data obtained were recorded and evaluated, and then the effects of different parameters on the process were observed. The data obtained will be usable for scientific studies and will help the future studies and future compost machines to be developed. A research has been made to determine the necessary conditions for controlling the composting process. It has been determined that the mixing process that will provide mechanical disintegration of the wastes and aeration of the pile is effective in the composting process. It has been stated that the temperature inside the device should not exceed 40 degrees Celsius until the pH value is 6 for microbiological activity to take place. And then the ideal temperature of 55 degrees Celsius should be maintained. It was decided to operate the air pump in case of a decrease in the oxygen concentration in the system. It is important to make continuous measurements so that the wastes have 60% moisture at the beginning of the process and that the moisture does not fall below 40% during the process. While it is appropriate to measure the pH once an hour from the sensors, it was stated that temperature, humidity, and gas densities should be measured in every. It is planned to use the bokashi method, which enables the fermentation process of compost to take place without disrupting the natural process of the fermentation. With this method, the time taken for microorganisms that will cause the decomposition of organic wastes to naturally form in the mixture is reduced to perform the fermentation process and create the environment for fertilization. In order to observe the effects of particle size in bokashi method on the composting process, 4 controlled experimental setups have been set. The operation of the sensors have been provided using Arduino Mega. Different gas sensors are used to measure the nitrogen, oxygen, hydrogen, carbon monoxide, butane, and propane gases that will occur during the fermentation process. It is planned to measure the moisture level and temperature of the mixture to form the compost with the help of the sensors to ensure that the important parameters of the fermentation process remain at the optimum levels. While monitoring the pH value of the mixture, which influences the quality of the compost in the process, the data received from sensors will be recorded time-dependent by using the real-time clock module is planned. Arduino Mega was preferred as the development board. Software has been developed with the Arduino's natural programming language, C and C++. The project has been designed with a multidisciplinary approach in which microbiology, mechanics, electronics, and software fields are worked together. Long experimental processes must be performed, which the effects of other parameters on the process are maintained by keeping one of the parameters affecting the composting process constant.